So hello my dear viewers and also my dear students, welcome to this question on calculus. I'm teacher Michael Samuel. So the question on calculus says that the diagram below represents the sketch of the curve y is equal to 12 plus 2x minus x squared, and the line y is equal to 8 minus x. The line intersects the curve at points A and B. So this is the curve y is equal to 12 plus 2x minus x squared, and we have this linear, the straight line, which is y is equal to 8 minus x, and therefore we are required part of the question to determine the coordinates of point A and also point B, that is the intersection of the quadratic graph and the linear graph. And then part B of the question, we are going to use integration. We are going to use integration to find the area enclosed by the curve, the x-axis, and the points AB. Then part C of the question, we find the area of the shaded region. So the shaded region is the area, in our case, shaded in green color. So we can begin with the part A of the question. So part A of the question requires we determine the coordinates of point A and B. So from the general understanding, we need to know that the intersection of the curve and that straight line, that is at point A and point B, their coordinates will be the same for both curve and the straight line. And therefore, we are going to equate the two equations. So the first equation is y is equal to 12 plus 2x minus x squared. We equate to the second one since the point of intersection for the two will be the same, is equal to 8 minus x. So we can simplify this and rearrange it like that. This case, let us take minus x squared to the right hand side. That will be x squared. Then 2x, we take it to the right hand side, will be minus 3x, and therefore we have 12. That will be 8 minus 12, that will be minus 4. Everything will be equal to 0. And therefore we have simplified this equation, and it has formed a quadratic equation. So for this quadratic equation, we have to solve for x, and in that case, we are going to get two solutions. So we use a factorization method. So product AC will be 1 times minus 4. So the product is minus 4 x squared, and therefore I need factors of minus 4x squared such that when I add them, I'm going to get minus 3x. And in my case, the factors would be minus 4x and x. If we multiply them, we get minus 4x squared. If I add, I get minus 3x. And therefore, I'm going to rewrite this quadratic equation, the middle part, in the expanded form. So that will be x squared, then minus 4x plus x minus 4 will be equal to 0. Take into pairs and then factor out. So x squared and 4x, x is common. So for x squared divided by x, I get x. Minus 4x divided by x, I get minus 4. Close the bracket, then plus In this case here, x and minus 4, 1 is common, so x divided by 1, I get x, minus 4 divided by 1, I get minus 4. Close the bracket, it will be equal to 0. And therefore, for this one, I write it as x plus 1 into bracket, then multiply by, I take 1, whatever it is in the bracket, I take just one of them, x minus 4 will be equal to 0. Either x plus 1 is equal to 0 or x minus 4 is equal to 0. Therefore, x here will be equal to minus 1 or here x will be 4. And therefore, for A, the minimum value of x coordinate will be minus 1. For B, the maximum value of x coordinate will be 4. As per this will be 1, this will be 4. So to get the coordinates of A, so when x is minus 1, so what will be y? How are we going to get y? So y will be, you can substitute in either of the two equations. Just in any of the two equations will give us the value of y when x is minus 1. So for this it will be 9 minus 1, which will be 9. And therefore, in this case, A is minus 1, 9. Then when x is 4, the value of y will be what? Again, we substitute into either of these two equations. So when x is 4, so y will be 8 minus 4, which is 4. And therefore, in this case, point B, the coordinates of point B is 4, 4. So that is part A of the question. We have been able to get the coordinates of A and B. Then part B of the question, we use integration to find the area enclosed by the curve and the x-axis between the points A and B. We use integration. So we're going to use integration to get what? Area enclosed by the curve, the x-axis, and the points A, B. So how are we going to arrive to this answer? We already know that the range, the minimum is minus, or the lower limit is minus, x is minus 1, and here the upper limit is x is equal to 4. Therefore, to get area by integration, I hope the question here is very clear. To find the area enclosed by the curve, the x-axis, and the points A and B. So that is it. So we shall be able to get, it's actually the all of this, that is the curve, the x-axis, and also the points A and B. So I hope that is very, very clear. And therefore, the area will be given by, we are going to integrate from the lower limit to the upper limit, value, and in our case, the lower limit is minus 1, upper limit is 4, and whatever we are going to integrate is the curve, which is 12 plus 2x minus x squared we integrate with respect to x. If we integrate, so we are going to get, if I integrate 12, I'll get 12x. I integrate 2x, I will get plus x squared. I integrate minus x squared, I'll get minus x cubed over 3. And everything is under what? The limit from -1 all the way to 4. Then the values of the upper limit, values of upper limit is when b is 4, and therefore we substitute into this. We have 12, x is 4, then plus, and x is 4 squared, then minus, x is 4 cubed over 3. If you work out this is 48 plus 16 minus 21 and a third. So we end up getting 42 and 2/3 square units. That's the value of the upper limit. And therefore we need also to get the value of the lower limit. That's when x is -1. We substitute into this integrated value. So we shall get 12 multiplied by x is -1, then plus x is -1 squared, then minus this is -1 cubed all over 3. So I end up getting -12. This will be +1. Then here it will be, remember this will be 1 over what? 3. So that will be plus, remember this will be -1, so it will be positive a third. So we work this out, we get -10 and 2/3 square units. Finally, subtract the area. We get now the difference since we are integrating between the two limits. So we have 42 2/3 minus, so -10 2/3. So if we work this out, this will be 42 2/3 plus 10 2/3. So we end up getting, this will be 50. That will be, get 53 1/3 square units. And that is the area of the part enclosed by the curve x-axis and the points A and B. Then part C of the question, calculate the area of the shaded region. So in our case, we need to find the area of this shaded region, and that is the area shaded in green color. So for us to get the area of the shaded region, allow just me to project this. I just draw this part here where x is -1 and here x is 4. Remember, we found that at this particular point b is 4 4, so the y coordinate here is 4. That is the height, and the other side we found that it was -1 9, and therefore the y coordinate, the height here is 9. Now For us to get the area of the shaded region, therefore we need to let me just write it, area of shaded region will be given by area of curve, area bounded, area enclosed by the curve, x-axis, and the points A and B. So the all of that, in other words, it's actually this area that we got in part B of the question. The all of this area, then we subtract this area, which is trapezoidal in shape. We subtract area of this trapezium. So we already know the area enclosed by the curve x-axis and the points A and B, which is 53 and a third square units. We got it in part B, and therefore the area of the trapezium, it is a half A plus B multiplied by the height. So a half AB, that is 9 plus 4, and in our case the height is the difference, the range, 4 minus 1, that will be times 5. So we end up getting, that is 32 and a half square units. And therefore, now to get the area of the shaded region, it shall be the area bounded by the curve x-axis and point A and B, which we got is 53 and a third, then minus area of this trapezium, and I found that it is 32 and a half. And therefore, if we work it out, we end up getting 20 and 5 over 6 square units. The other case could be the combined equation for the two, the one we got in part A. In part A, this equation here, x squared minus 3x minus 4 is equal to y. That is the combined equation for the two. We can easily be able to work it out. That is y is equal to, now it will be 4 plus 3x minus x squared. We work it out, and the range will be to get that area just from minus 1 all the way to 4, and integrate 4 plus 3x minus x squared with respect to x. So if you do the same, you work out, you will end up getting 20 and 5 over 6 square units. And that is how you do the question. So thank you so much for watching. If you haven't subscribed, kindly remember to subscribe and support my channel, and be ready for more video to come. Thank you so much. All the best.